2.4. This is me, KHAVISHKHA from CCG2 presenting this. The first question is swap nodes in pairs. The problem statement is given a linked list, swap every two adjacent nodes and return its head. You must solve the problem without modifying the value in the list node. Now first let's understand the first part of the problem description. Assume this is as a linked list as 1, 2, 3, and 4. We need to swap the two adjacent nodes. 1 and 2 are adjacent, so it is swapped as 2 and 1. 3 and 4 are adjacent nodes, hence it is swapped as 4, 3. Now let's come to the second part of the question, which means that you must solve the problem without modifying the value in the list nodes. Assume this as the node where this part contains the data, this part contains the address to the next node. The second step part of the problem statement describes that we should not change the value in this node. For example, this is initially it is given as 1. We should not change it to 2, 3, 4, etc. We should not change this value. We should only change the links like this. That is stated here. Solve the problem without modifying the value in the lists node. Now, come to the approach of how to solve this. Initially, we need to traverse the linked list from the head to null. While traversing, we need to swap the alternate nodes with the next node. Let's understand with the basic diagram here. Swap 1 and 2 first, next swap 3 and 4, and next swap 5 and 6 as 6 and 5. And since 7 has no pair, we end up with the null. And 7 has been placed there as such. Basically, this is the idea of what the problem statement describes. Now let's come to the logic of how to solve this. I'm taking the head node 1 as previous and head dot initially I'm assuming basically what we need to do is 1, 2, 3, 4 should be linked, should be changes 2, 1, 4, 3. What here is in the link is 1 is given to 4, 2 is given to 1, and the 4 link is given to 3, and 3 is given to null. This is the changes. That's what. So what we are going to do here is first I am taking the head is equal to previous and head dot next is equal to current. I am creating a temporary node called temp in which I am storing the variable previous. So we need to connect now. So for connection, what we can do is this one should be connected to 3, which is previous dot next is equal to current dot next. So the connection is established between 1 to 3. So now the list looks like this. Then we need to make the connection of this current. Current dot next is equal to prev, which is temp. Current dot previous is equal to temp. So this is temp. So current dot previous is equal to temp. Now what we need to do, make this as head. And so current is equal to head. By changing this way, the node is changed to this. What next we should do is, next is we should take this 3 as previous and this 4 as current. How this can be achieved? Basically, we know this is temp as of now. So temp is previous is equal to temp dot next. Current is equal to previous dot next. Assign temp is equal to previous. So by this way, we assign these ways. Now again by solving, we can swap into 2, 1, 4, 3. This loop is continued until previous is not equal to null and current should be also not equal to null, because if one is not equal to null and current is null, which means assume like 1, 2, 3. First we will swap this, then previous is not equal to null, but what is current? Current is null, so we have no pair to swap it, then we should not do anything in this. So we should check this condition before entering the loop. Now let's see the code explanation. Now let's see the code. Initially, the node is defined in a class called node, which has two variables, int data and node next. Data contains the value of the data, and next contains the value of the address in which the next node is stored. In the main function, int can represent how many number of nodes are there, and we get those many data. By getting, we call a function called insert. Basically, insert function is insert the current node to the end of the linked list. For that, if the head is null, we'll make the current new node as the head. Else, we'll traverse till the end of the list and we'll add there. Hence, we use this while loop to traverse till the end of the loop. Then we assign the new node at the last. Then we call the function swap alternate nodes. This is the function which is used to swap the alternate nodes. So, as we see there, as we seen in the as we seen in the uh, logic, if the current first node and next node is known, then only it will be returned. Also, initially head is written as previous and current is assigned as head dot next, and we made head to be current. We have checked that condition to check whether both the nodes are not null, to ensure that it has a pair, so previous is not equal to and current is not equal to. And what we did, we made connection from 1 to 3, which is temp is equal to current dot next. What we did connection from 2 to 1, which is current dot next is equal to previous. And we are checking whether next two nodes are empty. If next two nodes are or empty, then we leave it previous dot nexus. We assign the previous temp, so we use this previous dot nexus equal to temp. Else we what we need to do, one is assigned to 4, so basically one is next, one is previous here, so previous dot nexus one's link, which is to be true 4. Here what we assign temp is 3, so 3 dot nexus will be 4. So this is assigned here. Then 3 and 4 is assigned as previous and current for a next loop. Hence previous is equal to and current equal to previous dot. This is a code. And for display as usual, we are traversing till the end and we are printing the current node. Now let's run this code. First line represent number of nodes in that. Nodes are 1, 2, 3, 4. So it returns as 2, 1, 4, 3 and null. You can also remove this null to get the proper code. Again, you can run file with the odd number of nodes. Because there are 5 nodes, which has 1, 2, 3, 4, and 5. So output should be 2, 1, 4, 3, 5. Let's check. Yeah, the output was 2, 1, 4, 3, 5. The code is successfully running. Now let's see the time complexity and space complexity. The time complexity of n because we traversed till the end of the list where n represents number of nodes. So time complex O of n and space complexity. We haven't created any new list or any new nodes. Hence the space complexity is order of 1. Now coming to the next question. Next question is called capacity to ship packages within D days. Basically, first let's see the problem statement. The problem statement is a conveyor belt has packages that must be shipped from one port to another within days. Within days, the eight package on the conveyor belt has a weight of 8. Each day, we load the ship with packages on the conveyor belt in order given by weights. We may not load more weight than the maximum weight capacity of the ship. Return the last weight capacity of the ship that will result in the packages on the conveyor belt being shipped within days. Basically, what this question says is we'll get an array of integers which represents the weight and we get a number of days. In this, we should find what is the minimum capacity that we can send in each stage such that within 5 days we can send all the weights. Let's illustrate this. What we can do is initially we can send 1 to 5 in first day. So what will be the sum of this will be 6, 12, 15. Sum of this will be 15. And next day we can send 6 alone separately. And next day we can send 7 alone separately. Next day we can send 8 alone separately. And next day we can send both this as 19. Now what will be the maximum thing? It will be 90. This is the maximum amount that we spend per day. What are other possibilities? We can send all these 10 in one day, which is the weight will be 55. Else, we can send 10987 in one day, remaining plus 1 in one day, and 3 separately in one day, 2 separately in one day. So this has the maximum weight, which is of 27. So the maximum weight is 27. Now what we need to do is we should minimize this maximum weight sent per day. So this is what the question. I hope we got a clear idea of question. You can read explanation given here. A capacity of ship 15, actually 15 is the minimum here. How it is 15 in the sense, first we are sending 1 to 5, which is 15, and 6, 7 we are sending, which is 13, and 8, 9, 10. So out of this, which has the maximum 15. Except this way, if we try to fill in any other way, we get the maximum is more than 15. Hence, this is the correct order. And most importantly, eh, the way in the order we are sending the weights, which means first we are not filling 2, 3, 4, and then 1 here. We should fill it in the order. This is one of the given constraints. Let's see how to solve this. Basically, from this question, what we can infer is the weights may be what what can be the weights. One's weight can be the maximum, which is we can send each thing in a separate thing. The weight can be as 10, because if the weight is less than 10, less than this last element, we can't send this last element. I hope you can understand like what I'm going to say. If the weight, this maximum weight is less than this maximum, then we can't send this package itself. So at least the weight should be maximum, or else we can send all these packages in a single day. So then what will be the weight? The weight will be 55. So what is the weight possibles? It can be the maximum or sum of all or sum of all. Here in this case it should be 10, greater than or equal to 10, and it can be till 55. This can be the possible weight. We have find out this. Using this now we can find now we can find. So the approach here is and first the basically the brute force or intuition what we can get from this question is extremely naive approach is check all possible capacities. As we discussed what are the all possible capacities, the maximum weights which is 10 given and sum of all the weights which is 55 given here. From all these, if we solve out every time if we check it through a single for loop by the condition required days is less than or equal to d. Basically, first let's read the whole algorithm and let's see either in what we did is we will use a loop to check the all possible capacities. That is what we found out. In this case, as 10 to 55, and then we will find using a function find days. We used to find that. So basically, what given is in the main function, as usual, we are passing that weights, a number of weights, and we are calling a least weight capacity. In the least weight capacity function, we are finding the max, that range from maximum to sum. So how maximum can be found in the all the weights? If we add every weight, we get the sum of all the weights. And for maximum, we can check which is the maximum given there, and we are passing that as the limit here for the for loop, and we are finding the number of whether the days should be is less than or d. If the days is less than d, then we are directly adding it to the then we are directly returning it to a. So what is this find days function? Basically, initially the days is 1 and the load is 0 and n is kept as weights dot length. We are iterating till 0 to n number of n number of elements, that is n number of packages here. First we are adding the first we are adding the first byte to the load, and we are checking the capacity. We are checking the capacity. Where capacity is passes initially, which is I is the initial capacity, which is one on each iteration. Okay. Then initial capacity will be maximum, which is 10, which is the maximum capacity. If that is possible, then we are that is greater than, then we'll go to, if it the package is greater than 10, then we'll go to the next day. So which is days is increased, and the weight is added to load. That's in the same day weight is added to the load. Yes. And it will return the number of days. If we check in that way, the number of days is greater than 5. So this function will not be true, and again it will go into the loop where I is equal to maxi plus 1, in which in the example case it will be 11. So we'll pass as weights comma 11, and again we'll get into the loop. If the load plus weight is greater than 11, then we'll go to new date, which is we'll increase the date, and we'll add the weight. Else we will add the weight to the same day. So by these way, by doing iteration for every possible values, which is from 10 to 55, by doing iteration for every possible values, we can find which is the minimized minimum capacity we can use, so that we will return here. Let's try to run this code. Basically we get the minimum capacity should be 15, which is correct, we saw in the example. But what is the issue is, here the time complexity is over of n square, where because in this, for this function we get the time complexity, as was n, which means that there are n number of items, and sum of weights minus, which is for this n is for the first for loop, and this is for the second for loop, which is for here where the weights dot length is assumed to be as n. So this loop runs for n times, and this loop runs like the sum minus maxi plus 1 times this loop will be run. Approximately we can assume this to be also to be n. So n into n, it will be like n square, which is of quadratic time complexity. We usually will not prefer quadratic time complexity. Hence we need to optimize it. To optimize, we use binary search. The primary object of the binary search algorithm is to efficiently determine the appropriate half to eliminate, thereby reducing the search space by half. So in this, you can say like we need a sorted array to perform binary search. Of course, if we closely observe that we have the limits, like the limit should is 10 to 55. That is, we have the limits which is high and low. And of course, the list is sorted. If we see in the example, in the question, the weight is equal to 1, 2, 3, 4, which is this list is in the sorted order. Hence, we can apply binary search algorithm here. What is basically binary search? We will check. We know low and high. We know the range, so we can apply the binary search here. So let's see the algorithm here. Basically, this is the main function which we will get the weights from the user. After getting weights, we are calling the function ship within days. In ship within days, first we need to find the maximum, the limit, which is like what is the maximum and the sum of weights. That is done through this for loop, which is for int weight and weights. High is like sum of weights, which is high is always 55, it is sum of weights. So we are adding every weight. And what is low? Maximum in the given list. So this is the maximum. So add that max from low weight. And now we are calling a, instead of in this function we use a linear search. Basically we use a linear search from I to some, we iterate everything as which is linear search, so we got order of n. Instead of doing linear search here, we can use binary search, which is optimized here. So we are finding it by the required formula, and we are finding the count of, we need to know like number of days. Only then we can check, we can know how, which space to be eliminated. So for counting days, the same logic is applied. Initially, the day is 1 and the current load will be 0. If the current load plus weight is greater than the capacity, then we will go for a next day, and the current load for a next day will become outpaced to 0. Else the current load will be added with its weight in the same plane. So this is the logic which we use there same to count the days. After counting the days, if the required days is less than or equal to days, which means required days is what we find out. That found date is less than or equal to days in the sense which is we need to eliminate the right half. To eliminate the right half, what we need to do, I should becomes mid minus n. Else, if the required days is greater or equal to days, then we need to eliminate the left half. To eliminate the left half, what we usually do, lowest equal to multiples 1. So by this binary search, we can optimize the code to the time complexity of log n. Hence, for this case, the time complexity will be order of n for this and log n for this. Hence, the total time complexity will be like n log n approximately. So this is algorithm. You can have a look on this. So this is what same we explained there. As we discussed, the time complexity will be like order of n into log of which is sum of weights minus maximum weights, because this is the range we give. We assume approximately this is to be en, so it will be like order of n log n, which is more optimized than the brutal solution we saw before, which is of order of n square. And space complexity of order of n, of course we haven't used any extra space. Thank you, hope you have understood this.